Hi there, Physics 30. How's it going? I cut that last video a little too short here. I had two animations here I wanted to show you. This is it's called a Pixie machine, P-I-X-I-I machine. It's one of the first generators out there that produce electricity out of motion. So there's a little hand crank down at the bottom here. You can see I could change the speed of that hand crank there. Okay, I'm gonna just keep it nice and low. So as someone turns that crank, what they're turning here, they're turning these two magnets here attached to the crank at the top here. Okay? As they turn that magnetic field up here is changing. It's changing around these wires. And what I said last time, as long as the magnetic field is changing, you're going to produce current. So the magnetic field around these two coils of wire here are changing. There's like a soft iron core there for just to amplify the effects of the magnetic field. That's okay. We don't really need to worry about that. So the current is going to change. You can kind of see what's happening here. The current here, because it's going back and forth. Now, this would be the same if I left those on the top there and moved these ones around, very similar to the last example we had, where at one point we'd be going into the page, at another point we'd be going out of the page because of the direction of the magnetic field or the direction the wires are moving. So you could see that the current is going back and forth in opposite directions, like in and out, in and out, in and out. Very similar to what we had in this picture here, where it's going out of the page and then into the page and out of the page and into the page. So you're going to create this kind of alternating current back and forth, back and forth, back and forth. Now, if I wanted to create DC current, I can turn on the split ring commutator. It's a weird little device down here. It's very similar to, the idea of this is very similar to, it's going to flip-flop back and forth, changing the direction the current can flow. So you can see it kind of flip-flop back and forth as it goes. It's caused by this little semicircular dish here. So when it touches it, it plies up, and when it's not touching, it goes back the other way. And it just flips. So you can see on this little voltmeter down here, it's only going one way. Without it, it's going both ways. In, out, and then here it's going one way as well. Okay. And if I increase the speed, you can see that it increases the max voltage there, the max current. So that's how that one works. That's essentially what a generator is. You're just spinning either the wires or spinning either the magnets. Now, another useful application of this would be, say, an electric guitar. So an electric guitar operates a little bit differently than an acoustic guitar. Rather than plucking the strings and the sound vibrations amplify within the guitar, you pluck the string, and the string is made out of metal. Right? It can only be made out of metal for electric guitars. And that string is technically magnetized. Down here, before I pluck the string, there's a permanent magnet here. This permanent magnet is producing a magnetic field around the string, which is aligning the domains of the string. So let me just snip this so I can draw it. Okay. So it's aligning the domains within the string. So now the string becomes a magnet. So this is the north side. The lines are coming out of the magnet this way. There's a north on this side now because the domains are going to align themselves in that same direction. All right, so there's the north here, this is south here. All right. So now there's a magnet there produced by that magnetic field. And when you pluck the string, you move the magnet. And by moving the magnet, you're changing the magnetic field around, because right now the permanent magnet is not going to change around the wire. But when I pluck the string, this magnetic field caused by the permanent magnet now, or the magnetic string, is going to change around the coil. And if I pluck it, it's going to change the current here. It's going up and down, up and down. The reason it's changing is just like that, same as the example before. Either the coil is moving towards the magnetic field, or the magnetic field is moving away from it. So it's going up and down, up and down. It's changing direction. So it just changes it. The current is going in or out of the page. We'll talk more about that. There is a shortcut rule to determine that as well. Is it going to go, how is the current going to go? Is it actually going to go this way through the wire, or is it going to go back? Is it going to go this way through the wire? Is it going to go this way through the wire? Or is it going to go the other way? And you can see that as it goes up and down, it flips back and forth between the two. And then they use that electric current, this is what we call a pickup. You use that pickup the electric current to the amplifier, and then it gives you sound. You notice the frequency here is the same as the frequency of this moving string. All right. So that's all I want to talk about. Just a couple of applications of the generator effect, and then we'll talk about the Lenz's law in the next video. All right. See ya.